Amieroh Abrahams will be telling us how she uses R to detect marine heat waves.
Good afternoon, everyone. So I'm doing my master's at UWC. My supervisor is sitting in the crowd over there. And I'll be discussing, or rather the title of my task is detecting marine heat waves, okay? So I'll first give a bit of a background before I hit the basic R things. But anthropogenic mediated warming has resulted in negative impacts for both terrestrial and marine environments, right? And this is usually, or warming is initiated by climate change, right? And climate change is generally defined as a long-term rise in mean surface temperatures. Now, climate change, or research suggests that climate change may have influenced or increased the amount of extreme events. Extreme events being heat waves or cold spells. So for the purpose of this presentation, I'll be looking at marine heat waves specifically. And just a bit about it, during the 2015 and 2016, a quarter of our ocean experienced a marine heat waves. But now, what are marine heat waves specifically? So marine heat wave is defined as a discrete, anomalous, prolonged event, right? Warm water event. And by discrete, I mean that it has a distinct start and end point. And prolonged implies that it lasts for longer than 5 days. So marine heat waves have set metrics used to describe their properties. And these are the duration, the mean intensity, the maximum intensity, and the cumulative intensity. So marine heat waves have a range of consequences. Some of these include the dying off of large kelp, destroying our marine habitats, and resulting in habitat loss. But now also, there has been, or research suggests that people or locals on a beach may also detect a change in temperature as a result of the marine heat wave. So just back to detecting marine heat waves, the duration of the time series is very important when you are detecting a marine heat wave. And it is recommended that at least 30 years of data is needed to produce an accurate detection of a marine heat wave. So to obtain, or in the marine field, to gain 30 years of data is quite, it's not that easy, right? But there are different satellite sea surface temperature products, and this data is online and is available to the public, so we often just download our data from satellite products. And so for detecting marine heat waves, we have two packages that we use. These packages are produced by, or created by local South Africans, one being my supervisor and my co-supervisor. Supervisor being Prof. A.J. Smith. And yeah, it's quite often used, especially in the marine field, but this is not only restricted to marine heat waves, it applies to heat waves in the ocean or on land, or cold spells both on land or in the ocean. So just a bit about the functions within this data set. So yeah, I loaded the heatwave R package. Just to go back quickly, there are two packages, so it's heatwave R and R marine heatwave. And all of the, okay, I'm gonna go back quickly. So if you have a look there, there's a GitHub link to my co-supervisor's GitHub repository, and on there they have examples of how to use these functions, the different type of functions, what these functions do. So it's a good description. If you have no idea, you can just go up there and read it. Okay, so for the detection of a marine heat wave, basically all you need is your temperature column and your date, right? And we said that a 30-year time series is best. So having that data, we can use the TS2 climatology function, and what this does is it produces a seasonal, a threshold, and a variation, right? And now, just the next line. So just with 3 lines of code, we are able to detect and to plot a marine heat wave. So now we're using the detect function, and you substitute your data that you obtained from the first bit of code. Once it's substituted, it spits out a table that gives us the actual, it detects the event, and it demonstrates, or it shows us the different climatologies. And the last bit of code is the event line, and that creates a visualization because we like to visualize our data. And there you guys go. So what this graph is, it shows the temperature, the climatology, and your threshold. And the brightest color on this graph represents the most extreme or the most intense event happening during this time. Okay, and that's a sneak peek of Heatwave R. There's a lot more that you guys can do with it. I hope you do download it and have a look. It would be nice, but it's quite interesting. Thank you.